Welcome back. Today we are going to be doing proofs involving angles. So we've already done some segment proofs, and you're going to see some similarities here when we do angles, but really we're talking about the same thing. We're working through a logical sequence of events to prove something. And actually today we're going to introduce a few theorems. So starting with this one, we are going to start with the right angle congruence theorem, which just says that all right angles are congruent. Again, you probably knew that, but we're actually going to prove that theorem so that we can use it as a reason later on. So starting with the given, again, you guys by now should know number one statement is always going to be something that is given to you. Angle A and B are right angles, and that reason would be given. Now, as soon as you hear A and B are right angles, our goal is to prove here that A is congruent to B. And you may say, well, can't we just say that right afterwards? They're both right angles. Well, you kind of got to work through a process. So when you see here A and B are right angles, the first thing you probably think of is that they are equal to 90 degrees. So the second thing I'm going to write is I'm going to write the measure of angle A is equal to 90 degrees, and the measure of angle B is equal to 90 degrees. And the reason I know that is because that's the definition of right angles. And then you can say, okay, well, if they're both 90, then that means they're equal to each other. So the third thing I'm going to write down here is the measure of angle A is equal to the measure of angle B. And you can either do that through the transitive property. If you got A equals 90, B equals 90, cut out the 90 and just say angle A is equal to angle B. So you could say transitive property there. Or you could say substitution property, that you just replaced 90 degrees with angle A, or this 90 degrees with angle B. So you could do substitution property if you'd like. And then lastly, of course, if they're equal, we can finish our proof and we can say angle A is congruent to angle B, because if they are equal, that means they're congruent, because that is the definition of congruence, or congruent angles in this case. Congruent angles are equal. And there you just proved the right angle congruence theorem. So in the future, we're not going to have to put all four of these steps. We're going to be able to go from number one straight down to number four, and we would say A and B are right angles, angle A is congruent to angle B, and then your reason would become right angle congruence theorem. So just keep that in the back of your mind, that now that's a tool in your toolbox. All right. Going on to proof number two. It says if measure of angle ABC is 114 degrees, find the measure of angle DBC. Okay. In other words, prove angle DBC is 71 degrees. So statement number one, again, is going to be our given. Measure of angle ABC is 114 degrees. Given. I would also take the given from the picture. Like we've got angle ABD is 43 degrees. So that might be my number two. And I would pull this from the picture. Measure of angle ABD is equal to 43 degrees. That was given as well. Now you got to think, okay, how are we going to find DBC? So I'm thinking kind of like we did with segments the other day. We could add angles together to get the full angle. So I'm thinking that's angle addition postulate, and what that would look like in this picture is it would say measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. And the reason I know that is the angle, draw a better angle, angle addition postulate. Then we can fill in those missing parts. So like ABD, 43, plus measure of DBC, which we don't know at this point, equals the measure of ABC, which is 114. Now that would be the substitution property, because we substituted in. And then lastly, if we subtracted 43 on both sides, we would get the measure of DBC equals 71 degrees, and that would be through the subtraction property. We would have subtracted 43 on both sides. And that's our second proof on angles. Couple more theorems we're going to add. So we did the right angle congruence theorem. Now we're going to add in the congruent supplements theorem. And what this theorem says, it just says that if two angles are supplements of the same angle, or congruent angles, then the two angles themselves are congruent. So like let's say 1 and 2, for this example, add up to 180 degrees. They're supplementary. And let's also say that angles 2 and 3 are supplementary. They add up to 180. Well, angle 2 never changed, so that would mean that angle 1 and angle 3 are congruent to each other, because if angle 2 never changed and we're adding up to 180, 1 and 3 must be the same. So that's what we're going to prove here. We're going to go through and do this congruent supplements theorem so that in the future you can bypass all these statements and reasons and you can just say congruent supplements theorem. So starting with number 1, again, always going to be something given. This time they tell you in this particular problem, angle 1 and 2 are supplementary. Angle 2 and angle 3 are supplementary. That would be given. Now I put those both on the same line. Some people like to separate them out to two different lines, but since they're kind of saying the same information, I'm going to put them together. Now, as soon as I hear 1 and 2 are supplementary, 2 and 3 are supplementary, supplementary, of course, means they add up to 180. So that's going to be the next thing I write down, is that the measure of angle 1 plus the measure of angle 2 equals 180. Same thing with the measure of angle 2 plus the measure of angle 3 equals 180. What's my reason? Well, that was the definition of supplementary angles. Which takes me to step 3. Now, remember, our goal here is to prove that angle 1 is congruent to angle 3. So we got to keep that in the back of my mind. So we need to get 1 and 3 on the same line. We're going to do that right here. Since both of those expressions equaled 180, we could just set them equal to each other. Measure of angle 1 plus the measure of angle 2 should be the same as the measure of angle 2 plus the measure of angle 3. Now you can call that cutting out the middleman 180, or you can say you just replaced 180 with measure of angle 2 plus measure of angle 3. So you can either say, for your reason, that that was the transitive property or the substitution property. Next thing, again, I'm trying to get 1 is congruent to 3. Well, if we subtract the measure of angle 2 on both sides, we will end up with the measure of angle 1 equals the measure of angle 3. So that would have been through the subtraction property. We subtract equally on both sides. And of course, if they're equal, they're congruent, which is what we're trying to prove. So that's going to go last. And that is because that is the definition, again, of congruent angles in this case. Definition of congruent angles is that they're equal. We already said they're equal, so they're congruent. Again, in the future, you'll be able to go from 1 to 5 and just say reason congruent supplements theorem. There's also the same theorem for congruent complements theorem, which I didn't put on this list, but it would be the same thing. If one of the angles doesn't change, your other two angles would be congruent to one another. Just change the word supplement to complement. That's all. All right, next thing. A couple more theorems we're going to get into. Linear pair theorem, vertical angles theorem. Before we do that, you need to know what a linear pair is. You need to know what vertical angles are. So a linear pair, if you think about the word linear, linear means line. So this is a pair of adjacent angles whose non-common sides are opposite rays. In other words, they are two angles right next to each other. There's the fence line that makes them adjacent, and they form a straight line when put together. So that is a linear pair. And what the linear pair theorem says is it says if angle 1 and angle 2 are a linear pair, then they add up to 180 because a linear pair forms a line. Of course, you know the angle of a line is 180 degrees. That's called a straight angle. Vertical angles, on the other hand, these are like your backdoor neighbors. So we talked about adjacent angles. Vertical angles would be on the opposite sides of intersecting lines. So like 1 and 3 would be vertical angles. And what this vertical angle theorem says is that vertical angles are congruent. So like 1 and 3 would be congruent. Angles 2 and 4 would be congruent. They're also a set of vertical angles. So they're the non-adjacent angles formed by intersecting sides. And they'll be congruent, which makes that also relatively easy to remember. So here we go. Got a few pictures here. Just want to make sure everybody understands what those two are. So it says tell whether the angles are only adjacent and form a linear pair, or not adjacent at all. So angles 1 and 2. I'm looking right now. There's the fence line, so they're definitely adjacent. But the angle they form is not a straight line, so this adjacent only for that one. Going on here, angles 2 and 4. Angle 2 is up here. Angle 4 is in a totally separate, it's like across the street, so they are not adjacent, which means they also can't be a linear pair. So that one's going to be not adjacent at all. Moving on here to angle 1 and 3. 1 and 3. There's 3. Here's angle 1. There's the fence line between them. They're adjacent. And if you put them together, they do form a straight line. So that's going to be adjacent and a linear pair. You can try some of these on your own if you want to try these down at the bottom. Like angle 5 and 6, for instance. 5 and 6 are right next to each other. They are forming a straight line, so they are going to be adjacent and a linear pair. Angle 7 and angle SPU. Okay, here's angle 7, right there in the blue. SPU, now SPU is this entire angle, and they're overlapping, which means they can't be adjacent. And of course, if they're not adjacent, they can't be a linear pair either, because a linear pair is adjacent. Which leaves us with the final one, angle 7 and 8. They are not next door to each other, which means they are not adjacent. In fact, my next question would be, are they a vertical angle? And that would also not be the case, because if you look at angle 8 is formed with this line and this line. Angle 7 is not on the opposite side of that. In fact, angle 5 and angle 8 would be the vertical angles there. 5 and 8. They would be congruent to each other. They're formed by the two same intersecting lines. 5 and 8 would be a set of vertical angles. All right. So now that you kind of got an idea of adjacent, linear pair, vertical angles, I do have a couple more proofs we're going to walk through. This one is proving the linear pair theorem. And again, in the future, you'll just be able to go from 1 all the way down to the end. But for now, we're going to prove it. So starting with angle 1 and 2 form a linear pair. The reason there would be given. Of course, that was right there in the given information. I'm also going to use the picture to help give us some given information. Like BA and BC are opposite rays. You can see BA goes off to the left, BC goes off to the right. They form opposite rays, so that would also qualify as a given. Now, because they're opposite rays, they're forming a line, or you could call that, instead of line, you could call that angle ABC. And of course, a line or a straight angle is 180 degrees, which is what they wrote for number 3. Measure of angle ABC is 180 degrees. So we told them in step 2, we had opposite rays which formed a line. In step 3, we're saying that line is 180 degrees because that's the definition of a straight angle. Then I've got, on number 4, the measure of angle 1 plus the measure of angle 2 equal the measure of angle ABC. That's your angle addition postulate. Number 5, we had the exact same equation, except we replaced measure of angle ABC with 180 degrees, so that would have been the substitution property. You could also say transitive there if you really wanted to. And the reason for that is you had angle ABC equals 180, angle ABC equals 1 plus 2, so let's just cut out the ABC and call it equal to 180. So you could do transitive property as well. And lastly, if you know angle 1 plus angle 2 is equal to 180, that means that they are supplementary angles, so we can finish with number 6 with what we're trying to prove here is that 1 and 2 are supplementary, and I know that because that's the definition of supplementary angles. They add up to 180 degrees. So now in the future, if you get a linear pair, you can go straight down to 6. They're supplementary, and your reason would be linear pair theorem. Last one today. Prove the vertical angle theorem. Given that 1 and 3 are vertical angles, so you started that with number 1, that's going to be given. We want to prove that angle 1 and 3 are congruent, which is what we said from the theorem, that vertical angles are congruent. So let's work on proving that. So step 2, they wrote down that AEC, which if you look up there is a straight angle. DEB, also a straight angle. We're saying they're both 180 degrees. How did we know that? You know, it didn't say 180 degrees in the picture. We know that because that is the definition of a straight angle. Now in step 3, we got to start getting angles 1, 2, 3 involved here, because remember, we're trying to prove angle 1 and 3 are congruent. So they said angle 1 plus angle 2 equaled 180. Angle 2 plus angle 3 equaled 180. What they're doing there is they're doing the angle addition postulate. They're adding 2 smaller angles to get a bigger angle, 180 degrees. In step 4, they're cutting out the 180 and just replacing angle 1 plus angle 2 equals angle 2 plus angle 3. So you could say that was substitution property or transitive property. I'll write both just in case you picked one or the other. And then if you subtract angle 2 on both sides, that would be your subtraction property. You get angle 1 is equal to angle 3. And lastly, of course, if they're equal, they are congruent because that is the definition of congruent angles. And that's a wrap. That's some simple proofs on angles. Continue to work on the homework. Continue to show up with some of it done. Do your best, and we will answer all questions when you return. Hope you guys have a great day.